How's it going, guys? It's going off grid, and we have the last inverter for our inverter mashup video. I got 4 inverters that's going to be in this mashup video, and this one is the Reliable brand, and it's a 12 volt 3000 watt. These are the cables that they supplied with it. I may be using them, I may not be, I'm not sure exactly. And you got the normal stuff, you got extra fuses. And I haven't even opened this one yet. I just took it out of the box to show you. But this is the Reliable. And then we also have CNswipower 2000 watt. This is a 48 volt inverter. This is a 48 volt battery, 1.6 kilowatts. Then we have the Powerjack low frequency 3000 watt inverter. That's going to be competing as well. This is just my old 3000 watt Reliable 48 volt. This will not be competing, because, well, that's not the one they sent for this test. The one they sent for the test is this one. And this one's actually, it's funny, the story on this one. When I contacted them to see if they wanted to send an inverter, this inverter was sent for free for review. And so was this one. That was sent for free for review. I purchased this one because Powerjack won't send me anything. And when I asked them about an inverter, they said, you know what, we actually have one in the States. Someone bought it. It got shipped to the States, and right before it got to their house, they decided they wanted their money back. So it never even reached their house. So they ended up sending that one to me, which was nice. I did pay for shipping, and it wasn't very cheap either, because I paid for shipping it went all over the States, because I have a U.S. address. So it got shipped from one part of the States to the other part of the States, and then I had to pay for shipping from that part of the States to Canada. So I did pay for it, but I didn't pay for the inverter itself. Anyways, I can't wait to make this video, and I hope you guys like it. Hey guys, how's it going? It's going off grid, and today we're doing the big mashup inverter review. We're going to test all these inverters out, see if they can perform at their rated power, and then we're going to see which one is the best bang for the buck, what can produce the most watts per dollar, and we're going to see the sine waves of all these, under load, not under load. And I'm just showing you now my way of powering these inverters. So this is a 12 volt model. This is also a 12 volt model. Then we got a 24 volt model and a 48 volt model. 48 volt model can go with nice skinny little wires. It's a 2000 watt inverter. 24 volt model, the wires are about twice as thick. Plus they will be aided by 20 or 15 amp charger. And I'm running both my vehicles. I got 2 Jeep Grand Cherokee diesels, and they got 180 amp alternators. That's that there. And we're going to use that for 24 volts to run this. So that's 180 amps at 24 volts, or closer to 30 volts actually. And then I'm going to use the same Jeeps to power these two. Both Jeeps will be in parallel for this for 12 volts, so that should be about 360 amps. We'll be running through 2 sets of 2 gauge booster cable. Plus we have this battery pack here that can provide 200 amps per row of batteries. These are headway cells. These are LifePo 4s, and they can produce a ton of power. They are limited by these BMSs. They can do 100 amps each, but that's just for short periods of time. That won't last long because that's only 16 amp hours. Both these inverters are hooked up to each other, and so we should have no problems with input voltage on any of these inverters, because that's for the 48 volt, that's a 1.6 kilowatt hour battery, which will run this inverter at maximum, no problem. Anyways, we're going to start with the Reliable brand inverter. This is a 12 volt model. It is the highest wattage. So because this is the highest wattage, it was a little unfair, so I went with a 12 volt model. This inverter, if this was a 48 volt, I would say there's no comparison. It would probably blow all these inverters out of the water. But because it's a 12 volt model, I'm not so sure. We're going to be checking that. And this is a PowerBright 1500 watt inverter. So it's only rated at half the capacity, but it says it can do 1800 watts for 20 minutes. So that's pretty good. That's a cool feature. Then we got the Powerjack 3000 watt.
see what that can do. And the CNswipower inverter, I've already tested this in one video, and I'm going to test this again in this video. It's like a bonus. Let's get to it.
So here's my test set up here. Diesel Mercedes engine, 180 amp alternator, brand new energizer battery here. And I have the same vehicle here. Older Costco battery, but still works. And then we got the boosters coming to this battery, and then 2 more boosters coming off this battery, and it's going to my setup. We are sitting at 14.8 volts. These are getting a little bit overcharged, so I can't keep this going for too long. And we're going to start our test. So both of these have the exact same power setup going in. Here we go. Okay, so we are ready to test this because this meter can only handle about 1800 watts, and these are approximately 1500 watts each. We are going to be testing them each on this meter, and then I'll be plugging both of them into the inverter. So we'll be able to get a tally on how much they take total. We're sitting at watts right now. Hopefully you guys can see that. I'm gonna zoom you guys in here. There we go. If I hold it like this, you can see. There's our volts here. 120 volts. Looking pretty good. So let's see what this takes on high. 1380 watts-ish. You can hear the Jeep's engine surge when I do that. Oops. Keep that plugged in there. We're gonna unplug. Well, we'll leave the heat gun plugged in. We're gonna plug in the heater now. We're gonna heat her up to full. It's the highest setting on the heater. We're at 14.6 volts on the inverter. Output is 119 volts-ish. Oops, I didn't go all the way up on the inverter. There we go, or on the heater. This thing likes to ramp up very slowly. See what we get up to here. We're at 1100 watts. watts. Looks like we're settling at about 1250-ish. So 1250 watts in the heater. So we'll call that 1250. Now the heater is just going to get directly plugged into the inverter now. Right here. And we'll start with the heat gun. Then we'll turn the heater on. And we'll see what this thing can do, because that'll be approximately 2700 watts. That's almost its maximum. So let's see how it goes. If this really droops down to like 105 volts, that's definitely going to be the limit of the inverter. So there's high. There's our watts going up for just this. So we're at about 1400 again. So another 1250 is going to turn on now. There's 1250. We're sagged down to 11.5 volts, 109 on the output. This has gone up to 1450 watts now. So this is pulling more power than before. We're holding at around 11.5 volts in the inverter. We're sitting at 108 volts, so it's struggling. This is definitely near its maximum. Let this ramp up. This this heater likes to ramp up, but we're still sitting at 109 volts. That's actually very impressive. I'm surprised that this inverter, being 12 volts, can still do pretty much 3000 watts. Let's see if we can push it a little further. Shut this off for a second. I'm gonna get a 250 watt light bulb. Alright, so I added this 250 watt light. Let's start with that. Now I'll show you guys it does take 250 watts. It's plugged in.
see if you can see this now. Something like that. There's 256 watts. So that we're going to plug into the power bar here. And the power bar is going to be plugged into here. Light gets turned on. Then we're going to turn on the heat gun. Hopefully you guys can see this wattage here. We're at 1600 watts. And now let's turn the heater on. Okay, we're pushing at least 3,000 watts. Well, this has gone up, well, right around just under 1,600 watts. The heater's on and climbing. This is at bare minimum voltage, but it's still holding on. This is still usable, this voltage. Any lower than this, though, I'd say is too low. 110, 108 is a little low, but a lot of inverters actually come shipped only putting out 110 volts. So this is working really good. I'd say this inverter does actually put out about 3,000 watts. I'm pretty happy with that. And what's funny is the fans have not even turned on yet in this thing. So maybe I'll run this till the fans turn on. See what the volts are on this thing here. Oh, this one says 118 volts. I don't know if you guys can see that. 113 volts. Now went to 113.8. Back to watts. So this meter is actually incorrect. Actually, I gotta go get my oscilloscope. I totally forgot about that. I'll be right back, guys. Alright. I know it's a bit noisy because of the diesel Jeep there, but hopefully you guys can hear me okay. We got the oscilloscope right here. I turned the inverter back on. The fan's turned on immediately, so I guess the heatsink must have warmed up enough by now. Here's your sine wave. It actually looks very good. Let's see if we can look at that a bit better here. So it looks pretty good. Let's see if I can keep that in frame. Zoom out just a little bit. See what's going on. So the light is still on. And we're going to turn the heat gun back on. Heat gun is on high, as you can see. There's a tiny bit of ripple on the top, just a tiny bit. 1,670 watts here. We're going to turn the heater on high. And this dropped a little bit in wattage because we drooped in voltage a little on the output. And look at that, man. That sine wave still looks very good. That's crazy. It's gone a little tiny bit ripply, just a touch all the way around, but it's not looking too bad. Inverter is starting to whine. Inverter kicked out. It started dropping in voltage. We dropped to 10.8 volts, and it didn't like it anymore. It cut out. So we were pushing it right to its limits. Let's turn this back on, make sure it still works. Still works. That's awesome. So, looks like it does push its rated power, but 3,000 watts is its maximum. It's not going to really go over. Maybe for a couple milliseconds it will for surge, but that's it. Alright, time to go to the next inverter. Okay, now we're on to the PowerBright 1500 watt inverter. It's a very nice inverter. This inverter costs about 600 bucks Canadian, 650, depends where you buy it. This inverter costs approximately 400 Canadian. Sometimes you can get it less for about 350, depends on the day. And so this is supposed to be a higher end inverter. We'll see how it does. So let's turn it on. I have this light, this 250 watt light, plugged in immediately. And let's see if I can move this so you can see it. And we'll zoom in.
And we're going to go to watts here. We're pulling 287 watts. So there's more watts on this one. The voltage is fluctuating between 120 and it goes to 126 once in a while, which is weird, but this works just fine. Look at the watts, 187. See, it just jumped to 322. That was really weird. Sine wave looks really, really good. So let's put on a 750 watt load on top of that. Hopefully you guys can see this. We got 1089 watts. Sine wave still looks really good. And I'll turn this on. This is the input volts because these share the same power source. We're at 13.8 volts. Now let's go to high. So we are on high. We are pulling 1727 watts. Sine wave looks really good. It looks about the same as this one. It goes a little bit ripply on the top, and then it cleans up at the 0 point crossing, and then it goes a little bit ripply on the bottom side. But it seems to be working just fine. 1730 watts on a 1500 watt inverter. Output voltage is, volt amps. This is saying is 2000 watts. Interesting. But watts here. Oh boy, what's going on? This meter does not like what's happening right now. Very weird. It was up to 100. It said it was 130 volts output. It was doing some really funny stuff. Let's try volts again. We'll go high. 119 volts. It's working just fine. Maybe that was just a fluke. No, it's doing it again. Now it's saying it's 130 volts. We're at 11.8 on the input. Maybe that's why it doesn't like the lower input voltage. Anyways, I believe we found its maximum right there. 250 watt light bulb and a 1500 watt heat gun between these two. Alright, let's head over to the power jack. I gotta do a little bit of rewiring. I got to use the Jeep's power from these inverters. I'm going to turn it into 24 volts and use it on the power jack. Okay, we are now hooked up to the power jack. We got one set of booster cables at 24 volts. Both my Jeeps are in series, 180 amp alternators each. So this is getting a ton of power, more than it can handle. We also have two batteries behind it, just so you can see. It's just two lawnmower batteries. They're brand new. They'll offer a little bit of extra power if you need it. This is the voltage at the back of the inverter. Make it so you guys can see that. I think you can see that. I'm not sure. Make sure anyways. Okay, we're sitting at 29.8 volts. Almost 30 volts. We're going to turn this thing on. Immediately we got our light. So this is a this is a split phase transformer. So we got line 1, line 2. So to get full power, I need to be plugged into both these outlets. So one can really only do half power, a little more than half power. But we're gonna see what one can do before it trips with the watt meter. Oh, I'm gonna hook up the oscilloscope. Alright, there's your sine wave. It does not look very good in comparison to the other ones, but I guess it's still a sine wave because it still goes up and down. It's really weird though. It kind of goes up with a hump, and then down with the inverted hump. And this flat portion at the bottom, that's nothing. That's just going past my screen. So that's not. It's not like it's flat there. So we are still at 30 volts. You guys can see that. 29 volts, and I'm going to place this here as well, and we're going to turn the heat gun on. Turn it on 750. Immediately complains. What are we going to be at here? You can also see the light dims when I do all this. We're at 124 volts. There's watts, 230 watts. There's 750. The screen dims so far I can barely see anything. That is 750. It's saying 1500 watts on the meter, but yeah, maybe. Could be 1500 watts. The meter gets so dim you can't even see it hardly. That's saying 1500 watts, so that's alright. That's impressive, actually. Better than I thought. And if you look at the sine wave, it really goes to a square wave. It's not completely square, but it's getting there. This is saying 1600 watts now. Okay, let's try. Well, I might as well go to high. Maybe I'll turn the. No, let's go to high. So this is going to be 1500 watts plus 250. Let's see what we get here. It's almost a complete square wave now. The meter shut off. Oh, it just rebooted. So obviously we're way beyond what this inverter is capable of there. So I'm going to take this light off right here. We're going to unplug that. And then we're going to plug this 1250 watt heater directly into the other side of the transformer. So if this can hold 115 volts or higher, this will be pushing about 1250 watts. And we'll look at the sine wave. The sine wave with nothing running on it doesn't look too bad. It looks much better. Still at 29 volts. You guys see that? I think so. Okay. Let's start off with the heater. We'll just go right to high. What's going on here? It's working, but it's not putting out near as much heat as it normally does. I'm pretty sure this side of the transformer, oh yeah, that's right, this side was about 108 volts when I tested it, so it's not putting out near as much power. Maybe it drooped to like 100 volts, I don't know. Sine wave still doesn't look too bad though, and we're sitting at 28.6 volts. Now I'm going to go to low on this heat gun. We went to pretty much a square wave on the oscilloscope, and you can barely see the meter, but it's saying 1700 watts, which I don't believe. This thing doesn't pull 1700 watts. There's something funny going on. The inverter alarm turned on, so I'm going to switch sides now. I'm going to put the heater on the other side. I want to see what's going on with the transformer and the different legs. So let's put the heater on this side of the transformer, and we'll put the meter on this side. Turn it all back on. Immediately complains. Now it's putting out full heat. I can feel it. We're sitting at... Oh, it overloaded. It overloaded with 1500 watts. This heat gun wasn't even on. And our meters here, like I got tons of voltage going in. Sitting at 25.5 volts, square wave. Volts, we're sitting at... It says 170 volts, so it's complete square wave. This meter can't even read it right. Okay, just for fun, I'm going to put this one on high as well, just to see what this thing does. It turns on, and it's just cycling on and off, on and off. Okay, so I think we've confirmed it. This thing can barely do 1500 watts. With all the power in the world going into it, and at 1500 watts, it's a complete square wave. It's extremely disappointing. Anyways, let's go to the next inverter. Okay, now we're on to our last inverter here. I know some people have already seen me test this thing. This is the SNSWI power inverter, or CNswipower, however you say it. It's a 2000 watt. It's pure sine wave. Turn it on. Goes through a little self check. Then it turns on. Must have hit the probe there. There we go. Get your sine wave. Looks very nice. Get 121 volts, 120 volts, so it's fairly accurate. We have 49.5 volts input. I don't know if you guys can see that. So we got lots of power on the input. I'm going to go watts here. I have this heater. Let's see, I'm going to zoom out a bit here. I have this heater and I have this heat gun hooked up. So we're going to just leave the heat gun set to high. We are pulling 1600, 1500 watts, and then we're going to put, ooh, that was on. Was it on? Oh, there's a button underneath. There we go. Okay, so now I'm going to turn on the heater as well. You can see we're sitting at, or can you see that? 1470 watts. Now we're going up. 1840 watts, 2170 watts. Wow. It's surging pretty good, 2200 watts. It's complaining. We're still sitting at 120 volts. I don't know if you guys can see that. The sine wave was good. Oh, just overloaded. So it did 2200 watts for 5-10 seconds. That's very impressive. Very happy with that result. And then, obviously, it didn't burn out, I hope. Let's see. Nope. It's back on. Working just fine. And the heater turned back on. Look at that. Yeah, that's awesome. Passed the test once again. Overloaded it. No problems. Didn't die. So, let's put some of this stuff away and then we'll talk about these inverters.
Alright, so now we're on to bonus footage. We already know that from my previous videos, this cannot run this big compressor right here. This compressor takes a huge surge, it's super inefficient, and it blows half of the 15 amp breakers that I plug this thing into. Especially in the winter, it is very cold outside. So, why not test it on these inverters, see if they blow up. I already tested it on this one, it didn't blow up, but it just kept trying to start it. It kept turning on, off, on, off, on, off. It couldn't even turn the thing over, not even once. This one, on the other hand, was able to turn the compressor over slowly and kept trying to start it, just was incapable of starting it because this is a 2000 watt inverter, and that compressor takes at least 3000 watts to start. Most 3000 watt inverters can't start it. So this did a very good job attempting to start it. If it was a slightly smaller compressor, it would have started it. So this is a 3000 watt inverter. So let's see if this 3000 watt inverter can actually start it. It'll be very impressive. So this does have a soft start when you first turn it on. It starts at a low voltage and goes higher. So we're gonna just shut it off at first. We're gonna plug it in and give it its highest chance of starting it, which would be this way, and just see if it starts it. Now I'm gonna just turn this on. That's off, now it's on. Let's see, guys, is it gonna start it? Actually, you know what, I'm gonna put the kilowatt meter here. Alright, so I realize it's actually not gonna help me much because it's just going to boot up the second I turn it on, but here we go anyways. See if this thing starts it. No, won't start it. Maybe we need another set of booster cables, because I did unhook the one set when I did the testing on this. So maybe I'll get the other set and hook it up. Oh, it's so close. That's very close. Here we go. Third try. If you're ever going to blow an inverter up, this is how you do it. Oh, it's so close. Now we're going to try just plugging it in. That's probably the absolute worst thing you could do. This inverter does work at 15 volts, it looks like. That's awesome. Okay. There we go, people. No. Wow, that's got some good safeties too. That's surprising. I didn't know how, like, it turns on and off, on and off. It kind of, this just stays on the whole time and just lowers the voltage. This completely cuts in and out, so that's pretty cool. And neither of them have blown up yet, so incapable of starting it, it seems, but I did notice that my input voltage was kind of getting low. So one more time. Nah, 13 volts, it should start. So let's try the PowerBright. See if that can start it. Now this is way above what this PowerBright should be able to start. So it's a little scary. This actually could blow it up. And this PowerBright was not sent to me for review. I actually bought this one. Here we go. Let's see what happens. Nope. It tried though. That was impressive. One more time. Nope. It will not start it. So none of these inverters will start this compressor, which is crazy because I thought this compressor was running off a 48 volt version of this. This is the closest to starting it, but still will not start. Last time, just for good measure. It's a different cord now because I didn't have a long enough cable to get to this inverter. Oh, so close. Okay, well, that's it. That's the review. All these inverters did very well except for this one. Really like them. This inverter, I'm going to look up the prices. I'm actually going to print them out and put them on each inverter, and I'm going to do the math and tell you how much you get per your dollar. So this is how things turned out. 2000 watt inverter. This inverter was $290 Canadian. If you divide that by your watts, you get 14 cents per watt on this unit, which is a very good deal. 14 cents a watt is really good. And the Powerjack, this thing could only put out about 1500 watts, and it turned into a complete square wave. Almost, I consider this unusable, but I went by 1500 watts anyway, so that's 19 cents per watt. But this really can only push about 500 watts before it turns into a square wave per leg, so maybe 1000 watts. 1000 watts. Which would make that price go much higher. Probably another, maybe jump up to like 27 cents per watt. And then we got the PowerBright. This thing I actually found for fairly cheap on eBay, for $468 including shipping. It was new, advertised as new, 26 cents per watt, because this does deliver 1800 watts, and they said for 20 minutes. I didn't test the 20-minute mark, but I did run 1730 watts on this thing, and it powered it no problem. And then the reliable, this is on Amazon, found it for $378. It's 13 cents per watt. It actually ends up being the cheapest one per watt, which is surprising. This was priced from Amazon. This I priced from eBay because I couldn't find it on Amazon. This was priced from eBay because I don't think Amazon sells this either. And then this one was priced on Amazon as well. Now I do like buying from Amazon because their warranty is a little bit better than eBay's, but eBay's still pretty good. You still get a decent warranty with eBay. Amazon is longer though. A little more pricey on Amazon. So you could find cheaper prices on eBay most likely, or AliExpress even. But AliExpress the warranty is almost non-existent. Maybe a little bit of a warranty. And eBay, you get a little bit better warranty, and Amazon you get the best warranty I've found so far. And that's my review. Hope you guys liked the video. Hope I didn't miss anything, and I will see you guys later.